This is FE Peer Review. The date is still February the 5th, 2022. And this will be the second and last of my brief reviews of Kyle Adams' conversation with Mr. Sensible. This one is called Kyle Adams Doesn't Understand Light with Regard to the Inverse Square Law and Earth's Atmosphere. Kyle Adams gave us this lovely gem in his discussion with Mr. Sensible that has to do with the gradient of light related to the distance from its source here. I left a little comment, and this video is going to be an expansion on that. Luminosity Scale. Light diverges from the sun. Sometimes I wonder how Adams managed to graduate with his Bachelor of Science in Art. What we see when we look toward the sun in the sky is its visual effect as the light passes through our atmosphere. It is true that light intensity reduces with the square of the distance from the source, the inverse square law. But Kyle is wrong in thinking this has any noticeable effect on how we experience the sun's light here on Earth. Once the sunlight has gone from the sun to the outer edge of our atmosphere, it has traveled 93 million miles. After that, it has only a few miles to go to reach Earth's surface. This difference in distance is totally insignificant. The same is true at sunrise and sunset. The very slightly further distance it must travel is totally insignificant as related to the inverse square law. What does matter is that it is passing through much more atmosphere, and the gases of our atmosphere are able to have more effect on its path, color, etc. Now let's take a quick look at this snippet from the video of Mr. Sensible and his conversation with Kyle Adams.
Well, the other thing you had was light dims over distance, sunset,
Yes.
And you're saying about the sunset dimming.
Uh-huh.
Do you want to just expand on that a little? Just a little to explain your position and or what you're saying?
Okay, well, the light immediately around the sun, if we just look at the sky itself, all of the light around the sun is the brightest. We can actually get the luminosity scale of the sky, and as it gets closer to the sun, it's a lot brighter. But as we get farther away from the sun, it gets a lot dimmer. That's because the light diverges.
Well,
just like a candle. So my example, I can show you a picture, is of a candle in a room.
But it was the candle bit, wasn't it?
Yeah. But if there's any part of that video that you actually disagree with, I really want to know, because I would be very surprised if there's any part that, yeah.
Well, I've got the candle there. So what was it you wanted to say about the candle?
Oh, the candle is a nice example of this candle is a nice example of the gradient. We see the light gets a lot denser as it gets closer to the flame, and then it gets a lot more sparse as it gets to be dimmer the farther it gets away from the flame. And when we look at the sky, when the sun is out, the sky does the exact same thing.
So, Kyle, quite simply, you're wrong if you think that the distance to the sun being different at different times of day has any effect whatsoever on what we see when we look at the sun in the sky. It's not because of some kind of inverse square law that we are seeing something different at noon than we see at sunset. It's because the light's passing through the atmosphere. Now, I can't help wondering why you even go down this crazy path, except I think perhaps as a way to suggest that we actually have a local sun, a sun that's maybe just a few hundred or a few thousand miles up, in which case those extra 20 miles or 100 miles might make a difference in terms of the inverse square law. Well, I can say this for a start. No, we don't have a local sun. That's a bunch of hooey. That's stupid nonsense, and you know it. But if that's where you're trying to go with this, then do the math. Propose a possible height for the sun. I'm not saying you have to know what the height of the sun is, but say maybe it's 3,000 miles. Try 3,000 miles and do the math. How much difference is it going to make for a sun that's 3,000 miles up to pass through 20 miles of atmosphere versus whatever this distance is here. And I'll let you figure out what that distance is because I don't feel like doing your math for you anymore. So you figure out, if we call this around 20 miles, that's as good a number as any. 20 miles takes us to 1% of atmospheric pressure. You figure out what this distance is, and then you put your sun at, say, 3,000 miles, and you see how much that change in distance is going to matter. And then when you're done with the 3,000, since we don't know for sure it's 3,000 miles up, put it at 6,000 miles up, put it at 1,500 miles down, put it at a few different distances, and graph how much it changes, depending on the distance to the sun. I mean, do some work, for Christ's sake, instead of this stupid just blabbing whatever thought comes through your head, so long as it's contrary to what everybody else says. It is really childish and getting really tedious. You know what else you could do? You could go back to your alma mater, find 2 or 3 of your favorite teachers who are knowledgeable on subjects such as the inverse square law and light. I know you studied art and the science of art, so go back to your alma mater and talk to some of those professors and find out what they think about some of your wacky, screwed up ideas. And I'm sorry if I sound angry, but I'm really tired of your nonsense. This is why I don't review your videos anymore. I don't have any patience for you, so forgive me for losing my patience. I'm not going to edit this out because this is honest. I'm going to avoid doing too many more of these with you till you start to act like an adult. You need to do some work, some real work. I can't believe you're going to go through your entire adult life like this. It's just pathetic, really.